There are places in the universe where the laws of reality don't break. They simply stop working the way your brain expects. Places where radiation can sterilize a planet from thousands of light years away. And magnetic fields are strong enough to mess with atoms themselves. And the scariest part? None of this is hypothetical. These places are real. We've detected them. And some of them exist inside our own galaxy. Today, we're going through the scariest places in the universe, and what would actually happen if you got close. When people hear scary space, they imagine aliens. But space doesn't need aliens. Physics is enough. The universe contains objects so extreme that matter behaves differently. Time behaves differently. And survival becomes impossible long before you even arrive. Let's start with the most famous one. A black hole is a region where gravity becomes so intense that nothing can escape. Not a spaceship. Not a signal. Not even light. The boundary is called the event horizon. Once you cross it, you're done. What makes it terrifying? Real science. You can't send information back out. You can't reverse course. Every possible path forward leads deeper in. And deeper inside, gravity becomes uneven. That causes tidal forces. In simple terms, your feet feel stronger gravity than your head. That's what creates the famous effect called spaghettification. Your body gets stretched like a string. Not because the black hole pulls harder, in general, but because gravity changes rapidly across your body. Here's the part most people miss. The black hole itself isn't always the first thing that kills you. The accretion disk is. This is the swirling ring of superheated gas and plasma around many black holes. Temperatures can reach millions of degrees. And particles move near the speed of light. Accretion disks produce X-rays, gamma rays, and intense radiation. So if you got anywhere near one, you wouldn't have time for a dramatic fall into darkness. You would be cooked by radiation long before reaching the event horizon. Some black holes do something even worse. They launch jets. These are called relativistic jets. They're streams of particles accelerated close to the speed of light, fired from the poles of a black hole. These jets can extend thousands, sometimes millions of light years. And they're not weak. They are some of the most energetic structures in the entire universe. Why is it scary? Because if a jet was aimed at your planet from close enough, it could strip atmospheres, flood everything with radiation, and potentially make a planet uninhabitable. In astronomy, when one of these jets points directly at Earth, we call the object a blazar. And blazars are among the brightest and most violent things we can observe. Now let's move to something even denser than a black hole surroundings. A neutron star is what remains after a massive star explodes in a supernova. It's basically the star's core crushed into a sphere about 20 kilometers wide, with more mass than the Sun. Gravity comparison. On Earth, gravity is 1 g. On a neutron star, it's roughly billions of times stronger. If you got close, you wouldn't land. You'd be crushed instantly. And neutron stars are not calm. They emit radiation, X-rays, and high-energy particles. Some rotate hundreds of times per second. And every rotation sweeps a beam through space like a lighthouse. Those are pulsars. Now take a neutron star. And make it even worse. A magnetar is a neutron star with the strongest magnetic field known in the universe. Magnetars have magnetic fields so powerful that they can distort atoms, affect the structure of matter, and generate catastrophic bursts of energy. How powerful are we talking? If a magnetar came within about the distance of the moon, it could disrupt electronics across Earth. Not a theory. That's what the numbers suggest. And magnetars produce X-ray flares, gamma-ray bursts, and starquakes where the crust cracks under magnetic stress. When that happens, the energy release can be so huge that satellites in Earth orbit would detect it instantly, even if the magnetar is on the other side of the galaxy. Now we go to something that could actually threaten life. Gamma-ray bursts are the most powerful explosions ever observed. They happen when massive stars collapse into black holes, or neutron stars merge. They release in seconds what the sun releases in its entire lifetime. But the scariest part is this. Gamma-ray bursts don't explode evenly in all directions. They often fire a narrow beam. A jet. If Earth was hit by a nearby GRB beam, it could destroy the ozone layer, flood the surface with UV radiation, trigger mass extinction conditions, even if the burst was thousands of light-years away. This is one of the reasons scientists consider gamma-ray bursts as a possible explanation for some extinction events in Earth's history. Now here's the part people don't realize. There is a supermassive black hole at the center of our galaxy. It's called Sagittarius A. It's about 4 million times the mass of the Sun. The region around the galactic center is packed with dense star clusters, supernova remnants, radiation, and extreme gravitational interactions. It's basically a cosmic traffic jam of violent astrophysics. Why is it scary? Because the closer you get to the galactic center, the more likely you are to encounter intense radiation, gravitational chaos, and objects moving at insane speeds. It's one of the most hostile neighborhoods in the Milky Way. Sometimes, a star gets too close to a black hole. Not close enough to fall in immediately, but close enough for gravity to do something worse. The black hole's tidal forces literally rip the star apart. This is called a tidal disruption event. What happens? The star gets stretched into a long stream of gas. Part of it gets swallowed. Part of it forms a superheated disk. The system releases huge bursts of X-rays and radiation. From far away, it can look like the galaxy suddenly turned on a giant flare. It's one of the most violent things we can observe. And it's not rare. It's happening constantly across the universe. A supernova is the explosion of a star. But the explosion itself is only part of the danger. After the star dies, it leaves behind a region filled with superheated gas, shockwaves, high-energy particles, and radiation. This region is called a supernova remnant. Why is it scary? Because supernova remnants accelerate particles to insane speeds. These particles become cosmic rays. And cosmic rays are not harmless. They can damage DNA, destroy electronics, and penetrate deep into matter. If you were inside a supernova remnant, you'd be in a constant storm of high-energy radiation. Now we switch from heat and explosions to something equally dangerous. Extreme cold. Space is cold in general, but there are places where temperatures drop to almost absolute zero. Absolute zero is 0 Kelvin, which is about -273 degrees Celsius. Why does this matter? Because at those temperatures, chemical reactions stop, materials behave differently, and normal physics turns into quantum physics. One famous example is the Boomerang Nebula, one of the coldest natural places ever measured. What makes it scary? If you were exposed to deep space cold without protection, your body wouldn't freeze slowly. You'd lose heat extremely fast, and the vacuum would kill you before temperature even became the main problem. Cold in space isn't like winter. It's like instant system failure. This is the simplest scary place, and it's everywhere. The vacuum. If you were suddenly exposed to space without a suit, you wouldn't explode. That's a myth. But you would die quickly. What actually happens? You lose oxygen immediately. You pass out in about 10 to 15 seconds. Your blood doesn't boil, but liquids on the surface can start to vaporize. Your lungs can be damaged if you try to hold your breath. Radiation becomes a huge problem. So the vacuum itself is one of the most dangerous places in the universe. And it's the default environment. Now we go to something creepy in a different way. A rogue planet is a planet that doesn't orbit a star. It was ejected from its solar system. Meaning, a planet can be launched into interstellar space, alone. No sunlight. No seasons. No stable warmth. Just darkness. Why is this scary? Because rogue planets can drift through the galaxy undetected. Some might even pass through star systems. And if a rogue planet passed close enough to our solar system, its gravity could disturb asteroid belts, comets, or even planetary orbits. It's not likely. But it's real physics. And the universe has billions of planets. Now here's a scary place that is actually connected to us. The Oort cloud is a distant region surrounding the solar system. It's thought to contain trillions of icy objects, the source of many long-period comets. The Oort cloud is so far away that sunlight is extremely weak. Objects are barely bound by the sun's gravity. Why is it scary? Because if something disturbs the Oort cloud, like a passing star, it can send comets toward the inner solar system. That means some of the most dangerous impactors might not come from the asteroid belt, but from the deep outer solar system. And they could appear with very little warning. Now let's go even bigger. The universe is not evenly filled with galaxies. It has structure, clusters, filaments, superclusters, and in between, there are cosmic voids. These are enormous regions of space with almost nothing in them. Some voids are hundreds of millions of light-years across. Why is this scary? Because if you were inside a cosmic void, there would be almost no galaxies nearby. The sky would look emptier than anything we can imagine. And from a physics perspective, voids are important because they help us study dark energy, the large-scale structure of the universe, and how galaxies form. But from a survival perspective, a cosmic void is the ultimate isolation. No stars, no resources, no navigation, just darkness. Now for the final place. The edge of the observable universe. This is not a physical wall. It's a limit. It's the farthest distance from which light has had time to reach us since the Big Bang. Beyond that, there is still universe. We just can't see it. Why is this terrifying, scientifically? Because it reminds us of something important. No matter how advanced we become, there are parts of reality that might be permanently unreachable. Not because we lack technology, but because space itself is expanding. Some galaxies are moving away so fast that their light will never reach us, even at the speed of light. Meaning, there are places in the universe that are, by definition, outside our future forever. So what are the scariest places in the universe? Not the ones with monsters. The ones where physics becomes extreme. Where gravity tears stars apart. Radiation sterilizes planets. Magnetic fields distort matter. And the universe itself creates unreachable regions. Space is beautiful. But it's also the most hostile environment we know. And every time we discover a new, scary place out there, we're really discovering the limits of reality. Thank you for watching this video. Please subscribe for more videos. Have a good day.